Hey, hi, Lizette. The questions you asked about 20, 21, 26, 27. Here's the best walkthrough I can give you. This should be the same paper that you had that you were looking at. So the first thing we need to do is recognize that this shape here, this thing is going to be an octagon. Woo, sorry, I made the color change. This thing's an octagon. So what we start off doing is finding the measures of the angles. To do that, we had to do the n minus 2 times 180 thing to find the total. So in this case, 8 minus 2 times 180 gives me 1,080. And that's what all these angles add up to as a whole. So to find each one, you can see the answer is 135. We divided that among 8 angles and got 135 degrees for 8 angles. All right, and we know we could divide by 8 because it says it's a regular octagon. All right, second, this whole angle is 135, but what I want to do is focus on just this little angle inside the triangle. Well, this line that cuts from the vertex to the center, that's going to cut this angle in half. So I'm going to take this 135 and cut it in half. That's where we get this 67.5 right there. Because the angles are 135, and this is half of it. And that's giving us this little triangle right here. Now, if each side has a length of 20, then this part right here that only goes halfway across the triangle, that's got to be 10. So I have this 67.5 right here. I have this 10 here, and this 26.1 right here. If I wanted to know this side, which turns out to be this 24.1, we're just going to do the Pythagorean theorem. 10 squared plus x squared equals 26.1 squared, which you can see written out right here. When I solve that problem, I get 24.1. That turns out to be this missing measurement for the triangle. For that triangle, that distance is the apothem. So now I know the apothem of this shape, 24.1. So the formula for finding, let's see, well, we found the apothem. What's the perimeter? Sorry. For the perimeter, 20 plus 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 20 all the way around, we get 160. So if I want to find the area, it's 1/2 times the apothem, 24.1, times the perimeter, 160. That's where we get the 1,928. Problem 26 is basically the same problem with a different shape. 21, which pretty well matches up with 27. Now, I don't think, no, I'm sorry. For problem 21, we have two shapes. It says that these are two similar pentagons. This one has a side length of 10. This one has a side length of 12. So if I want to know what the scale factor is, 10 over 12 would reduce to 5 over 6. And that scale factor is the same thing for the perimeters. So the perimeters of these things, the ratio of the perimeters, pardon me, 10 over 12 or 5 over 6. Remember when we talked about the area, we had to square those numbers. So instead of 5 over 6, we square them both, 25 over 36. That's how we get the ratios for the areas. If the perimeter of the first one is of A is 40, what's the perimeter of the second one? These aren't regular, so that they're not all 10. Obviously, this one A would be 50, but it doesn't say that they're regular. So if this one has a perimeter of 40, and I want to find the perimeter of the big one, well, we just multiply by the scale factor. We're just going to take the 40 from the first one here times, in this case, times 6 over 5, not 5 over 6, because I want to get a bigger one. And that gives me the perimeter of this the larger one, which will be 48. Finally, for the area, we're going to do the same thing. The area of the larger one here, this one, is 252. How do I find the area of the small one? Well, we multiply by the scale factor again. But in this case, not the regular scale factor, it's the ratio of the area. So I have to use this 25 over 36. Now, if I have the measurement of B and I'm looking for the measurement for the area of A is going to be smaller. So I want to make sure I multiply with the smaller number on top. So we take the area of the big one, 252, times the scale factor for the areas, which is 25 over 36. I wrote it out twice. This is the same thing. These two here, this is 25 over 36 together, and we get 175. For problem 26, the first question, we're trying to find the perimeter. It's a regular pentagon. All the sides are 20 units long. So 20 plus 20 plus 20 plus 20 plus 20, we should get 100 for the perimeter. If we want to use if the whole side is 20, then this half is going to be 10. So I use the 10 and the 17 here to find the length of the apothem by doing the Pythagorean theorem. 10 squared plus x squared is equal to 17 squared, which is what we have here. The apothem turns out to be 13.7. Finally, to find the area, 1/2 times the apothem times the perimeter. 1/2 times 13.7 times 100 gives us the 685. This is a lot like problem number 20. And then problem number 27 is a lot like number 21. The scale factor between two similar triangles is 3 to 5. And then the area of the small one is 30. What's the area of the larger one? Well, we're just going to multiply by the scale factor, but we actually have to multiply by the scale factor squared. So it's not going to be 3 over 5 or 5 over 3. You square them. It's going to be 25 over 9. So it's 30 times 25 over 9. Here, I just multiplied by the scale factor twice. Same thing. But 30 times 25 over 9 gives us that 83.3. I hope that's helpful. Email me back if that's not, if you need more on any of those.